coming. If you guys could give me a nice big round of applause for Bryan McLellan.
All right, this is the general agenda. We'll work through a bunch of stuff. Chef's a really big topic, so I'm going to go through a bit of an overview of it. We'll talk about why you should be using Chef, and I'll show you the Nagios cookbook that we have in our community and how it works with Chef and how it's pretty slick. I was one of the original Chef developers. That was 5 years ago now. I've been in the Chef community the whole time. I work at OpsCode now, obviously. I did system administration for about 10 years, which meant I fixed broken things. I've worked in a lot of other areas, especially volunteer-wise. That's a picture of me somewhere in the desert solving traffic problems. You probably wouldn't know that the desert has traffic problems, but it does. So why did we need Chef? Who here considers themselves working in operations? Most of you? Responsible for servers? So originally, we needed to build a new server. We get some new hardware, physical hardware that we're going to build on. We talked to someone about buying it. The vendor would build it for us. It would get shipped to us. It would get installed. The operating system would get installed on it. And finally, our software application would get installed. Depending on the size of your company, each of these steps could take weeks. They could involve other departments. It took a long time. So it really didn't matter that much how long application deployment took, because everything else was already taking us a couple months. With the introduction of cloud, and now we have these large internal clouds, virtualization systems, all those other steps are immediate. They just happen. You can have a new server ready for you in the cloud in 30 seconds. So now it really matters how fast we can deploy our applications. There's a number of good reasons for doing automation. These are a few of them. Makes things faster. When you look at the automation scripts, you can see what you're building. You can rebuild things. You can rebuild your entire infrastructure from your automation. Sometimes we're talking about Chef. All you need to rebuild your entire infrastructure is hardware, your Chef repository, and a backup of your data. And ideally, you should be able to do a complete disaster recovery from that. However, when I got into automation, the reasons that I got into it was because it meant that I didn't have to spend time in building servers anymore. And that was awesome. That was the really impressive selling point for me. This is Adam Jacob. He's a friend of mine. He's the original Chef developer. Adam has a saying that operations is responsible for two things. The first is availability. Are the servers that you manage up and running? If they are, great. The second is efficiency. Is it easy for people to use those servers to get their business work done? Because your job isn't really just building servers, it's helping the business make money or do whatever it's supposed to do. So Chef's a configuration management language. That's what most people think of when they think of Chef. We like to call it also a systems integration framework. You can manage more than just your servers with Chef. You can manage switches, you can manage load balancers. The idea is that you can bring everything together with Chef and be a central point so everything can talk to each other. And that's why we call it an API for your entire infrastructure. There's a term out there that's called infrastructure as code. And we want to be able to write everything that we need to rebuild our entire infrastructure as code so we can rebuild it easily. When we started Chef, we had been using other configuration management tools, and we had some differing principles than they did, which was the reason we wrote Chef. The first principle of Chef is that it should be idempotent. Idempotency means that if something needs to be changed, it gets changed. And if it doesn't need to be changed, it's left alone. It's the if it's not broken, don't fix it thing. But it's really important in automation. Chef should be reasonable. So if you're running Chef on a Debian Linux machine, you expect it to use apt to install your packages. But if you're running it on a CentOS machine, you expect it to use yum instead. Chef has reasonable defaults whenever possible about how it makes its decisions, because we don't want it to surprise you. The core Chef language is primitives. This is like how many people consider themselves Unix people? A few? Most of you? All right. So in Unix, we have a lot of small tools, and we can put those tools together to build bigger things. Chef's built-in language is meant to do the same thing. The resources that we configure are primitives, and if you stack those primitives on each other, you can build bigger and bigger things. Chef should be scalable. That's a problem we had with other tools. We were building out these large, agile web startups that were just skyrocketing. They were Facebook applications that, ended up on a big website. Next day, there's hundreds of thousands of users that they need to scale immediately. And Chef should be hackable. Another problem we had with our other configuration management tools is they had an idea about how we should be building our infrastructure. And they didn't expect the kind of infrastructures we were building. So we wanted a tool that helped you do whatever you needed to do because you know your infrastructure best. And finally, Chef should be shareable. The cookbooks that Chef uses to configure your system were specifically designed such that you can write cookbooks that don't have your data tied into them. So you can share your cookbooks with other people, but just as importantly, other people can share your cookbooks with you. And we had problems with that in other tools we'd used previously. So this is a quick rundown of the different objects in Chef. And we have whole day classes on just this topic. So what I'm really hoping is that you'll walk out of here understanding what the different objects are, so that when you go to learn more about Chef, you can look up these objects and you'll have some idea of how they fit together. So Chef manages nodes. These are like servers, switches, load balancers, whatever you run Chef on. Nodes have attributes. Everything that we manage has information about it. We actually have a tool underneath Chef called OHI that collects all kinds of information about your system and stores it as attributes. So you automatically have all this information available that you can make decisions on. Like if you want to change how many services you run based on the amount of memory in your system, Chef already knows how much memory is in that system, and it can dynamically make that choice based on your code. Users and nodes authenticate to the Chef server as clients. Clients are an authentication object, while nodes are a data object. That's pretty important. To get work done, we write cookbooks. Cookbooks contain recipes. We take that joke really far. You'll find a lot of similarly named objects on the cooking theme. Each node in Chef has a run list. The run list are the things we want that node to do. The run list is a list of recipes. You can also have roles, so like a web server role, which can also contain a list of recipes. And this is where you start scaling your concept of what Chef's doing for you. You have roles for every type of server you have, and then you apply the roles to different servers. Rather than each server being a unique snowflake, you start thinking about, that's a web server, and if it goes down, I will build another web server, and it doesn't matter. I can replace that. Nodes can also be placed in environments. This is part of workflow. It's how you decide, well, these cookbooks are what I'm running in production. These cookbooks are what I'm running in staging, development. And finally, we have data bags, which data bags are named after bags. So this is a little bit of visualization. You can see from here that some of the concepts we just talked about. We have clients. The clients are the authenticator object. The nodes are what we're actually running. They can have run list. This run list contains a role. The role contains another run list which has recipes. In this example, we have 2 web servers which run Apache and PHP. And we also have a database server that's running MySQL and uses NFS for its data store. There's a man in our industry, his name's Andrew Clay Schaefer. He wrote the Meat Cloud Manifesto. This is part of this movement, of this agile movement in making things more automated. And one of the blockers to automation is we have all the software out there that's designed to be installed by a user. It's not designed to be automated. So it's really important in automation is that different pieces of software have an API so that you can use that to programmatically connect them together. So Chef was built on top of that idea.